what exactly is an algebra? I mean, here we are, we're going to be studying college math, which is all about algebra, and yet we don't exactly know what an algebra is. Well, an algebra is a structure, it's a system. It's a lot like the United States Constitution. Sorry about the extra quotation marks there. A sport, baseball, softball, wrestling, anything else. Building codes for new homes. The way the town sets it all up and the legalities of it. An algebra, in the mathematical sense, what it is it's a system that we can follow, a constitution of sorts. It's for reasoning our way with variables that represent ideas, notions, quantities that are often in the world all around us. It is, if you will, a sort of mental sport. And for it, we need to know certain principles or codes of standard to make sure that our conclusions are valid. Kind of like ensuring that our mental structure or our building will stand. That's what the Constitution is. The Constitution is a set of variables or players, if you will, like a sport has players. And those would be citizens and congressmen, senators, president, and so on and so forth. And there's certain rules or laws that must be obeyed in the Constitution. And in baseball, you've got your shortstop, your center fielder, your catcher, your pitcher, and a certain way that we have to do things. And if you violate that system, then it's wrong. For example, a balk in baseball. And if you violate building codes for new homes in an area, then you can suffer fines or you might have to rebuild your home. So all of those things lead to systems or ways of doing things. And that's what an algebra is. An algebra is a system or a way of logical reasoning that helps us understand how certain systems with numbers and variables work, particularly variables. In fact, if you say to yourself, what is an algebra? And you look it up in like some math jargon dictionary, it'll tell you it's an arithmetic with variables. What did I just say? I just said that an algebra is an arithmetic with variables. So if you can do an arithmetic, the thinking in algebra is exactly like the thinking in an arithmetic. As a sport starts with players, an algebra has players too. Some of these can be called variables and expressions. For instance, maybe I want to build a small development of homes. Let's say I don't know how many windows I'm going to need in total. Well, I want to have to order the windows, so I have to keep track. But I do know that there are 12 windows in every single house. So this much I know. If I take the number of houses and multiply that by 12, I can figure out how many windows I will need. Now, a minute ago, I just said to you guys that an algebra was an arithmetic with variables. Let's just change this a little bit, and let's say that there are 10 homes in this community, and every home has 12 windows. How many windows does the builder have to order? 10 homes, 12 windows in every home. 10 times 12 is 120. That's what you would need. But in an algebra, we try to think more abstractly than we do in an arithmetic. Same exact reasoning, but now I'm trying to figure out how many homes I'm going to put in my development. Maybe it's 10, maybe it's 20, maybe it's 15 or 25. So I'm just going to use a variable to represent whatever that might be. So I might call it X or N for the number of homes. I can't give you an exact amount for the number of houses, but I don't want to lose my train of thought. So in algebra, we have our players. A variable is X, like the number of homes. And an expression is 12X, which is how many windows, because every home has 12 windows. Are there better answers? Well, I went through that. Sorry about that. That's just a repeat slide. For some reason, it was going a little bit strange when I was working on this. All right, so let me backtrack 1 second. All right, so that takes me to where we were. Variables, and so let me just summarize the previous slide because it's a little awkward right now. When we said there were exactly 10 homes, then that means when we said there were exactly 10 homes, 12 times 10, you need 120 windows. Well, what if there are X homes? Well, then you need 12 times X, whatever X could be for the number of homes. And that's an expression. X is a variable and Y is an expression. And that's what we work with algebras. So algebras use letters such as X and Y to represent numbers. numbers that we don't know exactly what they are, but eventually we'll figure them out. If a letter is used to represent various numbers, it's called a variable. For instance, x, y, z, a, x sub 1, x sub 2. All of those are different variables. Variables in algebra, suppose you're building homes in a different development. This time you know there are 15 homes or windows in each home. You don't know how many homes there are, though. Write a variable for the number of homes, an expression for the number of windows. Well, the variable home for homes, any letter, like we used X before, but at the end it said, are there better letters? Well, in this case, I think H is a better letter to represent homes, okay? And the expression would be 15H because there's 15 windows in every home, so you're going to do 15 times H. If you're ever confused, is it multiply, divide, whatever it is, just change it out. Remember, an arithmetic is an algebra, and algebra is an arithmetic. Just change it out and say, okay, there's 10 homes. If there's 15 in every home, oh, then you need 150 because 15 times 10. Well, this time there are H homes because I don't know how many are, and I just need to write an expression for 15 times H. And we'll talk a little more about that and clean it up. But the bottom line is the expression is 15H. So I want you to notice the variable is the letter. Once again, what's the variable? It's the letter. And the expression is when we combine variables, sometimes with numbers and sometimes with other letters. That would be 15H. Okay. Now, an algebraic expression is a combination of variables and numbers, like the 15H that we just had. And it uses the operations of it: addition, subtraction, multiplication, divisions, as well as powers or roots called, and when we put it all together, we get an algebraic expression. Variables and expressions in algebra. So, for instance, suppose you're building yet another development with homes, but this development has style. So each house has two different types of windows. There are casement and double hung windows. You don't know how many windows are in each type of home we'll have. This time it's the number of windows we don't know. But we do know that there will be 25 homes. So here's your questions or your charges. Write an expression for the number of casement windows in the development. Then write an expression for the number of double hung windows in the development. Then write an expression for the total number of windows in one home. And then write an expression for the total number of windows in the development altogether among the 25 homes. Okay? So, again, you can pause this videotape to give yourself time to answer the questions. But an expression for the number of casement windows in the development would be 25 times C. Notice, it's very important that you understand, this is in the development. An expression for the number of casement windows in a house might be C, that would work great, or X or N, but there's 25 houses, so 25C is how many are in the development. How many double hung windows do you think there are in the development? 25D. Again, D for one house, 25 times D for the other house. Now you could have used another letter, but D makes sense for double hung. Now, write an expression for the total number of windows in one home, not in the development. That's number 4. In one home. What is the one home made up of? What kind of windows? Casements and double hungs. So if casements was C and double hungs was D altogether in one house, there should be C plus D. C is the number of casements, D is the number of double hungs. And then finally, for the number in the development, a couple of different ways to represent that. One way is to say, well, if the answer to 1 was how many casement windows are in the development, that was 25C, and the number of double hungs was 25D, well, just add them up, and that gives you all the windows in the development. Or you could say, well, wait a minute, the answer to number 3 for one home was C plus D, the casements plus the double hungs, that's in one home, and then there's 25 homes, so I'm going to do 25 times C plus D. So those are variables and expressions in algebra. Seem to be stuck right here. All right, so slide 11, slide 12. More variables and expressions in algebra. Suppose you're building in this time, oh, pardon me. Let me go back to this. Sorry. Lost track of where I was for a second. Suppose you're building homes in yet another development. This development has style. So this time, 2 different types of windows. We'll go to 3 different types. Casement, double hung, and bay windows. You don't know how many windows each house will have, but this time you know there will be 15 homes. Write an expression for the number of casements. Write an expression for the number of bay windows in the development. Write an expression for the total number of windows in one home. Write an expression for the total number of windows in the development. So the first one says to write an expression for the number of casement windows in the development. Casement windows, the whole development, 15 homes in the development. That would be 15C. 15 homes, C casement windows in each home. So I have to multiply 15 times C. Just like before, we said if there were 10 windows in every home and 12 homes, 12 times C would be 120. If there were 15 homes, 15 times 10, not C, sorry, 15 times 10 would be 150. Now there are 15 homes and C casement windows, so 15C. I don't know how many bay windows are in every home, so there's 15 homes, so 15 times B is the total number of bay windows in the development, not in a house, in the development. Number 3, now we're talking about one home. Write an expression for the total number of windows in one home. Well, the home's made up of 3 types: casements, bays, and double hung. So add them all up. Casement plus double hung plus bays. Usually we try to make things a little more comfortable in algebra, so we use alphabetical order. That's so that we can kind of find things where we expect them to be. We'll talk more about that as the year goes on, but it might make sense for now to write B plus C plus D. And you can do that all because everything's positive. You might think of it as the commutative property of addition for those who remember what that is all about. And as far as the total number of windows in the development, well, one way to do it is to reason it, because remember, algebra is reasoning, mathematics is reasoning, algebra is an arithmetic with variables, would be to say, well, there's B bay windows in every house, and there's 15 homes, so 15B. There's C casements, so 15C, and there's D double hung, so 15D. And add them all up, 15B plus 15C plus 15D. If you looked at it that way, you're 100% right. Or you could say, well, wait a minute, I'd look at it, I'd rather figure out how many are in one house first. So that would be bays plus casements plus double hung, B plus C plus D, and multiply it by 15. So that's 15 times B plus C plus D. Okay? All right. That will be the last of what we cover for class so far. After this, we'll talk a little bit about algebraic expressions and PEMDAS and order of operations when we get to our next lesson on Wednesday.